Hello again. In this video, we'll add some more programming constructs that will make our code much more interesting. We're going to talk about branching statements that allow us to change, or rather branch, the code's execution based on the evaluation of an expression. And we learned about expressions in the previous lesson. There are two Visual Basic branching statements, the if-then statement and the select case statement. Next, we're going to talk about arrays for collecting and managing groups of data, and we'll use that as a springboard to look at recursion statements. Recursion statements, also known in other programming languages as iteration statements, allow us to loop through each item in a group of data. We could change each item in the array, or evaluate it, or a number of different things depending on what we need for our application to do. The three iteration statements that we're going to look at are the for each, the for next, and the do while loop statements. And then finally, we're going to tie all three concepts together with a real life scenario to give you some context for why this stuff is so important. Okay, so what I've done is I've taken the liberty of creating a new project called Lesson 05, and on the single Form 1 that I have in my project, I've added a combo box, a list box, a text box, and a button. And in the combo box, what I've done was added items Bob, Beth, Conrad, and Grant. And in my list box, I've added the items, as you can see, foobar, Bazquirk, widgets, and gadgets. Okay? And we'll use this as the basis for the rest of our examples that we're going to use in this lesson. And let's first of all talk about the if statement, or the if-then statement. The if-then statement is the first of the branching statements that we'll talk about, and as I said in the introduction, the branching statements allow you to decide whether or not to execute a block of code based on the evaluation of an expression. So let's dive into some code, and we're going to just paste some code that I've written here a little bit earlier so you can see what I mean by the statement that I just made. Here we have example 1. In line 7, I have if combo box 1.text equal Bob, then we're going to pop up a message box that says you picked Bob, and then we're going to set the combo box text property back equal to an empty string. So you can see the syntax for the if-then statement. In fact, the if-then is encoded in blue text, so those are keywords in Visual Basic. And then at the very end of our if statement, we have the end if statement in line 10. And everything in between the if and the end if will execute if our expression combo box 1.text equals Bob equates to true. If it equates to false, then it will not execute these two lines of code, lines 8 and 9. It'll just skip over those. Okay, so let's run our application, test this out real quickly. You can see this in action. I'm going to select Beth, and when I click the button, nothing happens. When I click Bob and click the button, then you can see I get the message box, you picked Bob. So you can see how I'm able to branch the code execution by skipping over blocks of code or executing blocks of code based on the expression between the if and the then statements. Or rather, I'm sorry, the if or then keywords. All right, so let's move on to a slightly more complicated example. First of all, I'm going to select the lines of code here and comment them out like we learned how to do in the previous lesson. I'm going to paste in another example. Here we can see the use of the else keyword, and what we're able to do here is evaluate this expression. If it's true, we're going to execute the code block between lines 15 through 19. However, if this expression equates to false, we're going to execute the code block underneath the else statement in line 21. Messagebox.show you pick Conrad. Okay, so let's go ahead and run this. Oh, what? I'm sorry, there's one other thing I wanted to talk about here. Lines 15 through 19. Notice that I've embedded an if-then-else statement within the context of an if-then-else statement. So just be aware that you can embed your statements within other statements. So in this case, if this equates to true. So in other words, if the comma1 text is not equal to Conrad, then we're going to do another evaluation here. We're going to test this condition. If message box1.text equals Grant, then we're going to show this message box. Otherwise, we'll show this message box. I'm not sure who you picked. It wasn't Conrad and it wasn't Grant. Okay, so let's go ahead and run this. First of all, we'll select Grant, and you'll note that we get the message box because it met both of the conditions. Then let's pick Conrad, and we're going to execute our else statement. And then we'll pick, say, Beth, and click the button, and it says, I'm not sure who you picked. And that's exactly what we would have expected these lines of code to accomplish. Let's comment out this line and move on from here. Next, we're going to talk about the select statement, and the select case statement is a lot like the if statement in so much that you can execute a block of code based on the evaluation of an expression. But the select statement is better for those situations where you could have a number of possible branches based on the expression. So let me demonstrate this by pasting in another example here. You can see here that we have select case listbox1.selectedItem.toString. So we're going to determine which item was selected by the user in our list box. Then we have a series of case statements. If the case is foobar, then we're going to show this message box. If the selected item is BazQuark, then we'll show this message box. And if it's anything else, then we're going to show this message box. Okay? So notice here that we have this special property called selected item on our list box. This will return back to us which item was selected. And in a list box, multiple items can be selected, and we're going to demonstrate that a little bit later in this video. Then because the selected item is returned as an object, and we haven't talked about objects yet, but it's the base class for all of our data types, then we need to convert it to a string so that we can do the evaluation correctly. Okay? So don't really think about that too much. Just take it at face value. We'll explain more about objects and casting objects, things of that nature later on. What we want to focus on is this select case, this expression that we're going to evaluate, and how it compares to the various cases that we have within the context of our select case and select keywords. So let's run the application. We'll start by selecting foobar. We'll go on to BazQuark, and then we'll pick gadgets. And notice that gadgets executed that final case else statement. You pick something else. Okay. So you can see here that we have two different branching statements, and the difference is that each one has its strengths. Two different tools that essentially do the same thing, but are used in two different scenarios. In software development, you're often going to find that there's more than one way to do something, and it's not a matter of the right way versus the wrong way in many cases, but which method is more expedient given the current circumstance. So in some cases, the if statement is more elegant, and in other cases, the select case statement is a more elegant way of solving a programming problem that you might face. Now, which one do you use? Well, that takes a little bit of experience, and it's going to take a little bit more time to get familiar with these, and you'll begin to see the situations where each can be used effectively. We're not going to focus on that right now. We're just going to introduce these concepts, and then later on we'll reinforce these as we move through the series of lessons. But for now, let's move on to arrays. And in order to really get the most out of recursion statements, we're going to need to talk about arrays. An array is a type of collection that allows you to group together a bunch of values that are related in some way. So for example, you could have a group of values that represent a price schedule, or a group of values that represent the times that the bus is going to arrive at a given stop on its route. Or you can have an array that includes all the test results for a given classroom. Or you can collect together all the values that are stored in a list box. So any grouping of values together can be treated like an array. So let me define an array and then talk about it a little bit more. You can think of an array as just a regular variable, or to extend the analogy that we've used previously, a regular bucket. But this particular bucket has more than one compartment. Now you can carry all the things in the bucket, all of the individual items in their respective compartments, by using the single handle on the bucket. Okay, so to apply that back to what we're talking about here, you can see that I'm dimensioning a new variable that has 3 compartments in it. This is zero base, so think 0, 1, 2. Even though I've typed in the number 2 here, it's actually 3 items, 0, 1, and 2. So it has 3 compartments. But I'm going to be able to refer to each of those compartments by using the variable name myArray. And each of the items within the array are of type string. So that's one thing that you have to keep in mind whenever you're working with arrays, is that each element of the array has to be the same data type. In this case, each element of the array has to be of type string. So what we've done here is we've accessed each of the individual elements of the array by using an index, either 0, 1, or 2, in order to access the given compartment, or rather the given element of that array. And I have assigned the first element to Bob, the second element to Beth, and the third element to Conrad. In a like manner, I'm able to retrieve the values out of the array by using an index as well. Now in this case, what do you suppose will show up in the message box whenever we run our application? Let's go ahead and test it and find out. Okay, Conrad shows up, which is at the index of 2, our third element, because we have accessed the third element by using index of 2 within our array. Okay, hope that makes sense. Now, what were to happen if we were to try and put more information into our array than we have defined the array to hold? So what if we try to put another item in? What would happen? Let's run the application now. And we get a runtime error that says the index out of range exception was unhandled. And underneath the message, you can see that index was outside the bounds of the array. So you can think of the bounds as like a soccer game or a football game where you have boundaries. And if you go beyond those boundaries, you're out of bounds. Well, that is what has happened here with our fourth element of our array with an index of 3. We simply can't stuff any more into the compartments that we've defined whenever we set up our array, whenever we defined it. Okay, so let's go ahead and close that and stop our application. What I demonstrated in example 4, as you can see from my comments, was a sized array, which means that we have defined up front how many items will fit in our array. We can create an array in a slightly different manner by creating what's called an initialized array. You can see that I have here in example 5 dim my other array. Now this time I have an open and closed parentheses, but I have not defined the size of the array. But I have defined it as being an array of type string. And then I use the equal sign and then an open curly brace and a closed curly brace. And then I type in several values. I could type in as many values as I wanted to here if I was able to hard code them in advance. If I knew them in advance, I could use this technique. So you can see here that I've created Bob, Beth, Connor, and Grant. So what is the size of my array? Since it's 0 based, I would expect there to be, it would be the equivalent of creating this dim my array instead of 2, having a 3 there instead. So in this case now, whenever we show the message box and we're showing element 2, which one would you suppose that we would see? Bob, Beth, Conrad, or Grant? Let's run our application and find out. Conrad again, okay, because once again, he is the third element at index 2 within our array of strings. So to sum up examples 4 and 5, Arrays are very easy to understand. They're simply variables that can hold more than one value, and the way you access that value is through a parentheses notation using an index to access an individual element of your array. And again, the purpose for introducing arrays at this point was so that we could have something to talk about for our recursion statements. Recursion statements allow you to loop through or navigate through each item in an array or a collection one at a time. So let's consider example number 6. You can see that in line 49, I've created an array very much like the one that I created in example 5. Then what I do is use the for each notation, or keyword rather, to access each individual element of the array and display it in a message box. So let's take a look at this a little bit more closely. Notice that the first thing I do in line 51 is I create a new variable called person as type string. And what I'm going to do is use the for each statement in line 52 to grab out each individual string that's in my array, place it temporarily in the person variable, and then display the person variable in a message box in line 53. And we'll continue to loop through the code block, which is really only line 53, until we have gone through each and every string in my array. So let's see what this does. Let's run our application. We're going to click our button. We start at Bob, Beth, Conrad, Grant. Okay, so we loop through each and every one of them using our for each syntax. But this is just one of the ways that we can use recursion within our applications. Let's take a look at another example. And in this example, I use a different type of recursion statement called the for next statement. In this case, I define a specific number of times that I want to execute the code block in the loop. So I create an integer called I, and I initialize its value to 0. And then in the line number 60, for I equals 0 to 5. So what this says is that we are going to start at 0 and continue to increment the integer I by 1 each time we come to line 62, the next statement, until we get to the number 5, in which case then we will break out of our loop and continue on through the rest of our code. So let's run this application to see how this works. 0, 1, 2, 3, 4, 5. Okay? So this is great whenever you know how many times you want to loop through. You want to loop through a specific number of times, which may or may not coincide with the actual number of items within an array. Now, we didn't use this in the context of an array. You don't have to. As you can see here, I was able to use it just to display numbers, and there's a number of other ways that we could use this, but it's great whenever we want to loop through a specific number of times, and we don't want to just use the for each approach. Let's continue on to look at another way that we can use recursion. In example 8, we have an example of the do-while loop statement. And this one starts off very similar to example number 7, in so much that we're creating an integer called I. But notice line number 68. Do while I is less than integer.parse textbox1.text. So in this particular case, we're going to allow the user of our application to type in a number. We're going to parse that into a real number so we get it into the correct data type. And then we're going to continue to execute the code block, which is only line 69, but it could be more than that if we needed it to be. It'll continue to execute line number 69 as long as the integer I is less than the number that the user typed into the text box. Now in this particular case, the loop statement will not automatically increment our variable I to the next value. We have to do that ourselves. So you can see in line 69, that's exactly what I do. I plus equal 1. That's roughly the equivalent of doing this. I equals I plus 1. Okay? This is just a shorter notation in line 69. So you can see in example 8, using the do while loop statement, that I'm able to control how and when I want the iterator, the letter I, to be incremented to the next value. Okay, so now we can have some fun. Let me go ahead and comment this out, and I'm going to combine some of these ideas that we've been looking at together. And we'll uncomment out this example. Okay, so what I've done in this example is that I've combined an array and the branching statement. So in line number 76, you can see something that we've looked at about 2 or 3 times already, where we're creating an array that's initialized to having 4 values. Then we are going to iterate through each item in the array. Now I didn't use a for each statement. Instead, I chose a slightly different method. Here I'm using, in line number 79, a for next. So I'm going to go where I equals 0 to the length of the array minus 1. So whatever the length is, what is the length? Is a property of the array that will return the number of items, the number of elements in the array. So I'm going to set a breakpoint here, and we're going to watch this execute so we can see exactly how it works. But then, during and in the body of our code block in lines 80 through 83, we're going to evaluate the current element of the array, and if it's equal to Conrad, then we're going to pop open a message box that says, hey, we found Conrad. And then in line 82, there's something else that we're doing here that we haven't talked about yet, which is the ability to programmatically exit out of the loop. So I use the exit for statement. If we found Conrad, which is what we're looking for, then there's no need to continue looping through lines 80 through 83. We can just pop out of the next statement in line 84 and continue executing any code that comes after line 84. Okay, so let's go ahead and run this. Let's go ahead and start this off here and look at the length. The length is 4, so we're going to go from 0 to 4 minus 1. So from 0 to 3. That should work just right. Okay, the first item in my array, 1, is Bob, so that's not correct. We're going to keep looping through. This next item is Beth, and the next item is what we expect to see here, Conrad. So this should now work with our selection statement, our branching statement, pop open the found Conrad message box, and now we're going to exit the for loop and continue executing the rest of the code. So we just jump straight to the end sub and continue on from there. Okay, let's go ahead and stop that. So you can see how some of these concepts can be used together, and quite frankly, I do this a lot. Almost every day that I'm coding, I'll combine some of these thoughts together. Okay, let's do one more good example. This one's a little more complicated, or at least it flexes some different muscles that we've been developing here. You can see here we have recursion and branching combined in the form of a for next and a select case statement this time. So what we do in this case is take a look at all the items in the list box and only look at those items that are selected. So we're able to, in our list box, get a subset of all the items, only those that were selected, and get a count of those, how many items were selected. And then we're going to look at each of the selected items, and when we find them in our select case, then we will display a message box appropriately. So let's go ahead and save and run this. Let's select BASQuark. I'm going to hold down the control button on my keyboard so I can select 2 items. I'm going to click button number 1, and notice I get a message box BASQuark and gadgets. Okay, So that is pretty neat. Okay, so in this lesson we looked at branching statements, the if-then-else statement, and also the select case. We looked at recursion statements, actually several of them, the for next. We looked at the for each and the do while loop. And also before that, we talked about arrays, that they are basically single variables that can hold multiple values. And the way that we access each of the elements within the array is through the use of an index within enclosed within parentheses, right? And basically, these constructs will allow you to create intelligent applications that can more effectively respond to our users and make decisions based on the input that they supply. So if you enjoyed this video, please visit www.learnvisualstudio.net to download and watch over 400 videos just like this one, aimed at all skill levels on many different topics related to C#, Visual Basic, ASP.NET, and more. Thank you.